All right, welcome back. And today is our second day with scatter plots. Okay, so today we are going to talk about best fit lines, how we can find them. Today we'll kind of use maybe more old school method. We'll calculate some things. Then next week we'll start to use our graphing calculators more and figure out how we can put that into practice to save us some time and get maybe a more precise answer. So today, to start off, a best fit line is a situation where we have a line that is y equals mx plus b. Okay, so slope-intercept form. And this line best represents the data on a scatter plot. It's usually going to pass through 2 points, can pass through more or less depending on the situation. Okay, and these best fit lines will only work in the case when we have a linear scatter plot. So, first thing we're going to do is graph this point. We're going to create our scatter plot. Once again, I mentioned the other day, you can count by fives and put those marks. You don't have to, but I like to do it because it kind of helps you see the whole graph a little better. Okay, you can go a little quicker when you plot then. All right. So now we got to plot these, 1, 2, 3, 4, 5, 6 points. Okay, so 3, 0, 5, 2, 7, 3, 9, 6, 11, 9, and then 15, 11. All right, so as you can see, it's not perfect, but generally if we trace this, it is linear. It's a line, okay, with a positive correlation. Now, it says here, draw a best fit line through the points 5, 2, and 9, 6. So 5, 2 right here, 9, 6 right there. To draw a best fit line, let's see if I can do this. It has to go through those points. So it looks something like that, okay? Now, obviously, it would keep going, but it should go through those 2 points. Now, as you can see, some are on the left side above it, some are on the right side. It kind of goes through the general mass. Okay. Now, it says find the slope of this best fit line. So in order to do this, we need to go back. This is something we used at the very beginning of the year. You used it in Algebra 2. You probably saw it in Geometry. Probably in Algebra 1. You've seen it every year, but our formula for slope, just y2 minus y1 all over x2 minus x1. Now remember, the x always comes first. It doesn't matter which point is 1 or 2. The key is whatever you put first. So if I put the 6 first, I have to match it up with the 9 first. They have to be lined up. So if this is our x1, y1, x2, and y2. Now, all we have to do to find our slope, use this formula. So we'll do 6 minus 2 all over 9 minus 5. So here's what I'm talking about. If I put the 6 first, the 9 has to go first because they are a pair. If I would have put the 2 first, the 5 has to go first because they are a pair. Okay, they have to be lined up with their partner. Now, 6 minus 2 gives us 4. 9 minus 5 is 4, and that reduces to 1. Now, over here, it says write the equation of the best fit line. So what is the equation of this line we drew? We know it has a slope of 1, which, as you see, up 1 over 1, up 1 over 1. Where would it cross the y-axis? And we could just trace it down if we wanted, or we can use this other formula that we have learned, y minus y1 equals m times x minus x1. So remember, that is our point, this is our point slope form. So up here we had slope intercept form, and here this is going to be our point slope form. And we have 1 point and 1 slope. Now we know the slope is 1. So we're going to fill that in for the m. Then you can choose either of these 2 points. It doesn't matter which one you choose, and you're going to plug it in there. When you solve it, you will get the same answer no matter which point you choose. So I'll use 5, 2, just smaller numbers. It'll be easier maybe, but it does not matter. So y minus the y1, which in our case is 2, equals 1 times x minus x1, which in our case is 5. Then we distribute this in. Y minus 2 equals 1x, or just x, minus 5. And we're almost done the final step. We'd have to add 2 to both sides. We get y equals x minus 3. All right, and then finally it says describe the correlation of the scatter plot. I already talked about this. As x increases, so does y, so this is positive correlation. Now, this one was just kind of a general scatter plot. There was no real context to it. So now, let's flip it to the next one, and here we're going to have some context. So it says, this data shown represents the age of a child in months and their weight in pounds. Use this data to analyze the scatter plot. Okay, so we got to start by graphing. Now, this time the number's already there. You can see when I printed it, some of them got left off on the left side here. I think I put that weight in pounds too close. So here 12, that's 14, 16, 18, 20, 22. You might need to write that in so you know it keeps going. 24, 26, 28, 30, 32, 34, 36, 30, etc. Okay, so finish that out. Okay, so now at this point we're going to plot. So I'll plot these in red. 19, 22. So 19 is halfway in between the 18 and 20. And then 22. Oops, I put that at the wrong spot. Okay, so it's easy to make a mistake. You got to be careful on these when you're doing it. But 19 and 22, then go over to 21, and it goes up to 23. Then 24 will be at 25. Okay, so I know this can be a bit tedious, but we just got to do our best to carefully graph these. So 27, 28 up here. And 29 will be at 31. 31, 28. Uh, 34. Let's see, that's 32. And then finally, we got 2 more, 38, 34, and 43, 39. So, it is not perfect, but hopefully you can see it is linear and it has a positive correlation. Okay, now, it says draw the best fit line through the points 24, 25, and 34, 32. So, once again, those points, let's see, 24, 25 right there. And then, what was the other one? 34, 32. So 34, 32 is right there. Okay, so I will draw this line as straight as I can between those 2 points. As you can see in our case, some are above, some are below. It kind of goes through the middle. Some of them it kind of brushes up against, but we're not sure if it perfectly touches. This is kind of our estimate here that I drew. Now I need to find the slope of that best fit line. And then we want to say, what does that slope mean? Because now we have context in this problem. Okay. So the first thing we're going to do here is go ahead and once again, we'll use our slope formula. So 32 minus 25 all over 34 minus 24. We'll get 7 over 10. You could leave it like that, or you can write it as a decimal 0.7. Now, if we interpret that, what does that mean? So we know that on top is 0.7 represents the weight, the increase in weight per month. Okay, so 7 over 10 means it goes up 7 pounds every 10 months. We kind of broke that down, divide by that, we get 0.7. So 0.7 pound increase every 1 month. Okay, so each month that increases, or each month that passes, the child will gain 0.7 pounds. Now, is that exact science? No, but this is kind of our estimation based on the data. Okay, it's our best fit line, so it's kind of an approximation of what we see happening. Okay, so now we need to plug that 0.7 in once again, and we'll do this y minus y1 equals m times x minus x1. So we got to find the best fit. You can use either one, so it does not matter. I'll use the first point, y minus 25 equals 0.7 parentheses x minus 24. We distribute that. So y minus 25 equals 0.7x. Now 0.7 times 24, you could use your calculator. You'll get negative 16.8 right there. All we got to do then is add that 25. Now be careful because it's 25 and it's a negative 16.8. So if you need to, use your calculator. Or you can do 25 minus 16.8 if that's easier to think about it. And whoops, instead of an equal sign there, I need to have a plus sign. But I have now my, my equation here, my best fit line. Okay, now, when we the reason we can use this, we can do two things now. We can either interpolate based on the data or extrapolate. Okay, so interpolation, this is when we make a prediction about something that is within the data's high and low. So within the data, high and low, okay? So what I mean by that, right here, this first one, it says predict the weight of a 30-month-old. 30-month-old, this will be interpolation. So if we look up here, 30 months is between the low of 19 and the high of 43. So 30 would fall right here. If we were going to interpolate this, we would take our calculator. We'll use this equation here. So 0.7, then we'll times it by 30 because that's how many months it is, and get our answer plus 8.2. And this should give us a good prediction. So 29.2 pounds. Now, if we go look at our picture here, 29.2 for a 30-month-old, so over 30 up 29.2, that'd be right around there. That's right in the midst of our data, okay? So it's pretty realistic. All right, now this next one, predict the weight of a 5-year-old. Now, somebody may think a 5-year-old, this is in months. So you're right, we got to calculate that. A 5-year-old, how many months would that be? And we know there's 12 months in a year, 12 times 5. It's a 60-month-old. Okay, now that's a weird way to think about it. So this is going to be an example of extrapolation because 60 is higher than our high, which was 43. So we go in here. Anytime you want to get that same equation, I can just hit second, enter, and then scroll over, and I'm going to change that to 60. Okay, so we get 50.2 pounds. Okay, so now here's the problem. Sometimes when you extrapolate, it's not always going to be realistic. Okay, so predict the weight of Mr. Fox. To do this, we need to extrapolate. because I am definitely older than a 43-month-old. Now, first, I don't know if you guys know this, I am 29 years old. Okay, so if we do 29 times 12, we can find out how many months it is. Okay, so 348. And technically, if we want to be precise, my birthday's in July, so it's been 5 more. So we add 5 to that, and right now I am 353 months old. Now, we'll go ahead and get back to that. So I need to do 0.7 times 350 plus 8.2. And according to this, I weigh 253.2 pounds. So as we can see, it breaks down. It's not always the case. It's possible that someone my age could weigh that much, okay? But hopefully when you guys see me, you don't think I weigh that much. So that is how we do that. So if you have any questions about this, there is one more example in the packet. And if you'd like to see it, talk to me. I am happy to go through it with you. But I kind of want to stop now just because this video is getting a little long. But hope you guys have a great day. Make sure we do the assignment, and I'll talk to you later.